All right, so here's the CAPS Unit 5, Day 13 answer key. So we'll get number 1. So with this one, I see that each term has an x in it. I'm going to factor out that greatest common factor first. And then we get x squared plus 8x plus 15. Then what's left in those parentheses, we're going to try to factor that. So I look at the factors of 15. There are 1 and 15 and 3 and 5, and I'm looking for factors that add up to 8. And that would be 3 and 5. So this becomes x, and then x plus 3, x plus 5. So the instructions say factor it, which we did, and then find the zeros. And that's it. Yeah, so all we do is we set each of these factors equal to 0. So we do x equals 0, x plus 3 equals 0, x plus 5 equals 0. And so this first one's already solved. We don't have to do anything there. The second one, all we have to do is subtract 3. And then the third one, all we have to do is subtract 5. And just a reminder, they don't ask us to do this, but if we had to, this would cross at 0, at -3, and at -5. So it looks something like this. I'm not going to do that for everyone, but just so you know what they're going to look like. Okay, number 2. I notice 3 and 48 are both divisible by 3. So I'm going to pull a 3 out. Then they both have an x in them, so I'll pull an x out. And what's left is x squared minus 16. And then I'm going to try to factor what's in the parentheses if it is factorable. Actually, you know what? You don't have to. Well, it does say factor, so we'll do what's instructed of us. It is factored, but we can factor it further. So, but if you're just finding the zeros, you could just set each of these equal to 0, and you'd get all 3 answers. So we need numbers that multiply up to 16. 1 and 16, 2 and 8, 4 and 4. They multiply up to -16, and they have to cancel out and add to 0 because there's no x term in the middle. So it would be +4 and -4. And then you set each of these factors equal to 0. Then we solve. So first one we'll divide by 3. 0 divided by 3 is 0. Here we'll subtract 4. 0 minus 4 is -4. And on the last one we'll add 4. We get x equals 4. All right, let's slide over to number 3. This one we're going to factor right away. We don't have to pull out a greatest common factor because there is not an x in each term, and 1, 29, and 100 have a common factor of just 1. So what we're going to do is we're going to look at what are the factors of 100, and there's a bunch of them. 1 and 100, 2 and 50, 4 quarters, so 25 cents each, right? 5 and 20, and 10 and 10. Which of these will multiply to +100 but add to -29? And that would be -4 and -25. So this ends up being x squared and x squared. That's going to be how we get x to the 4th. And then x squared minus 4 and x squared minus 25. Now, whenever you have a, let me grab a highlighter here, a squared number, so if you have x squared minus a square number, and what I mean by a squared number is if that number is something squared. So 4 is 2 squared, and 25 is 5 squared. Whenever you have x squared minus a square number, that's factorable. And so, I don't want to use yellow. Let me back up here. So the first one can factor into x and x, and then plus 2, minus 2. So if it's a square number, you take the square root, and that's the two factors, one positive, one negative. The same thing here, x minus 5, x plus 5. And we should have 4 answers because it's an x to the 4th polynomial. And so we're going to set each of those equal to 0. X plus 2 equals 0, x minus 2 equals 0, x plus 5 equals 0, x minus 5 equals 0. And then we just solve them, subtract 2, we get x equals negative 2. Add 2, we get x equals 2. Subtract 5, we get x equals negative 5, and then you add 5 and you get x equals 5. All right, let's go down to number 4 here. Excuse me. So on this one, there's not a greatest common factor. There's also not it's not like the last one, so this is going to be a factor by grouping situation. So we're going to group the first two terms and the last two terms together and separate those by a plus sign. And then we're going to factor out a greatest common factor out of each of those parentheses sets. So in the first one, we're going to take out an x squared. What's left is x minus 4. And then in the second, we're going to take out a negative 5. And when we divide both of those things by negative 5, we end up with x minus 4. And what we want is each of these to have the same factor in them. And then we can basically just pull that out. So we take that x minus 4 out, and what's left over is x squared minus 5. Okay, that's fully factored, so that's as far as we can go. We can't factor the x squared minus 5 because the 5 is not a square number, like 4 and 25 were in the last one. So we're going to set each of these factors equal to 0. Here I'm going to add 4, and I get x equals 4. And then on this one, I'm going to add 5. Excuse me, I get x squared equals 5. And then I square root, and I get x equals the square root of 5, or x equals negative square root of 5. And then if you wanted, you can change that to a decimal by plugging it in, or you can just leave it the way it's written here. Get rid of that little dot that I don't need. All right, so let's look at number 5. This one has an x in each term, so I can pull out a greatest common factor here. We have x squared minus 10x plus 24. And then let's see if we can factor what's inside the parentheses. Not 25. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Those are the factors of 24. We're looking for something that's going to multiply to positive 24, but add to negative 10. And so that's going to be negative 4 and negative 6. It could possibly be negative 12 and positive 2, but when you multiply those, you do not get positive 24. So that combo wouldn't work in this situation. It would only work if the 24 was negative. Okay, so our factors are going to be x, we already got that one, x minus 4, x minus 6. And then we set them equal to 0. And this one's already solved. The other one we're going to add 4, we get x equals 4. And this one we're going to add 6, and we get x equals 6. Marvelous. All right, let's slide over to number 6. So on this one, I can pull out an x. We're left with 8x squared minus 2x minus 15. This one's going to be a little bit tougher to factor. So 8x could be from either 8x, or 8x squared could come from 8x and 1x, or it could come from 4x and 2x. And I am going to guess it's 4x and 2x just based on that middle term. That since it's minus 2x, that's pretty small. If we did 8 and 1, those are pretty far apart, so the chance of getting negative 2 is kind of tough. So let me just play around with some options here. So negative 15 is going to be 1 and 15, or 3 and 5. Since these are pretty close together, I'm guessing it's 3 and 5, and let's kind of put those in and see if that works. So let's try 3 here and 5 here. That would be 20x and 6x. That's not going to give me negative 2x, so that didn't work. Let's undo all that. Let's try switching them around. 5 and 3, does that work? This is going to be 12x, and that's going to be 10x. If we have a positive 10 and a negative 12, that will indeed give me that negative 2 that I'm looking for. So how do we make negative 12? Well, that would have to be a negative 3, because 4x times negative 3 is negative 12, and then it'd have to be 4x plus 5 to give us that plus 10x. All right, it's a very patriotic looking problem so far. So 4x minus 5, 2x minus 3. We're going to set each of those equal to 0. And then we're going to solve each of those. So I'm going to add 5 to both sides on this one. We get 4x equals 5. Divide by 4. We get x equals 5/4. On the other one, I'm going to add 3. We get 2x equals 3. Divide by 2, and we get x equals 3/2. So our three answers are 0, 5/4, and 3/2. All right, about halfway done with this first side here. So on this one, we can take out an x squared. And what's left is x squared minus 25. And then that one we can factor into x and x, and then plus 5 minus 5, because we're looking for numbers that multiply to negative 25 but cancel out to 0 when you add them up. So we've got y equals, or excuse me, I don't need that. We're going to set each of these equal to 0. So square root and square root of 0 is just 0, so this would be x is 0, and this happens twice, you know, because technically you have to have two answers when you have an x squared. It's called multiplicity of 2. On the other one, this would be minus 5, so we get x equals negative 5. And on the other one, we add 5, we get x equals 5. So we have three answers. Technically, we have 4 because 0 happens twice, but as far as where does it touch the x-axis, it'd be at those 3 spots. Okay, number 8. See, I can pull out an x here. And this one should be a little easier to factor than the previous one, because for 3x squared, the only options are 3x and x. And then for 2, it's just 2 and 1. And so I think it's going to be 2 and 1 like this. Let's check. So that's going to be 6x and 1x. If I make the 6x negative and the 1x positive, we would get negative 5x. So how do I get negative 6x? That would be a minus 2 here. And then to get positive 1x, I'd have to make that a positive 1. So this is, once again, I don't need the y. We would set each of these factors equal to 0. first one's done. That was easy. Next one is 3x equals -1 divided by 3. We get x equals -1/3. And then the last we add 2 and we get x equals 2. All right, number 9. This is another factoring by grouping because there's an x to the third, an x squared, an x, and a constant term. So we're going to start by grouping the first two terms and the last two terms and separate those by an addition symbol. And then I'm going to factor out a common factor out of those sets of parentheses. So this would be x squared. And then on the other one, I'm going to factor out a -2. And that turns into x plus 3 as well. Because if you do -2x divided by -2, you get 1. And then -6 divided by -2, then you get the plus 3. All right, and then since there's a plus 3 in each term, we can pull that out. And what's left over is x squared minus 2. All right, so x plus 3 equals 0. X squared minus 2 equals 0. I'm going to subtract 3 here. I get x equals -3. And then I'm going to add 2 to both sides. I get x squared equals 2. Square root, we get x equals square root of 2, or x equals -square root of 2. So those are our 3 answers. And once again, if you haven't noticed, this is an x to the third, so there has to be 3 answers. If it's x squared, there's 2 answers. X to the fifth, there'd be 5 answers. We're not going to do x to the fifths, by the way. All right, so this one is, I hope, factorable. Either that or I made a bad worksheet. So 18 is, let's see, 1 and 18, 2 and 9, and 3 and 6. I want things that multiply up to positive 18, but add to -11, and that would be -2 and -9. All right, the first one is not factorable. That's as far as we can take that. The next one we could factor because 9 is a square number. So this would be x minus 3, x plus 3. Once again, you want numbers that multiply up to -9 that add to 0. That's how I knew it was that. All right, so let's solve each of these. I'm going to add 2 to both sides. We get x squared equals 2. Square root both sides, and we get x equals square root of 2, or, ooh, it's an ugly 2. Let's try to fix that. There we go. Or we get x equals -square root of 2. Over here, we're going to add 3 to both sides. We get x equals 3. And then subtract 3, we get x equals -3. All right, number 11. Let's see, 18, 60, and 50 are all divisible by 2 for sure. I think that's it. So, and an x, we can pull out an x. So this would be y equals 2x. And then we'd have 9x squared minus 30x plus 25. And this one's going to be a little bit trickier to factor. So 9x squared could be 9x and 3x, or 9x and 1x, or 3x and 3x. I can see right away it's 3x and 3x. I'll explain why in just a moment. And then 25 is either 1 and 25 or 5 and 5. And it's going to be 5 and 5 because I noticed that 3 times 5 is 15x. And 5 times 3x is also 15x. And that would give me -30. So as long as these two are negative, we're good to go. So this is, once again, I don't need that. We're going to set each of these factors equal to 0. 2x equals 0. 3x minus 5 equals 0. And then the other one's the exact same, so I don't need to do that. So we get x equals 0 for the 1. And then we add 5 to both sides, and we get 3x equals 5. Divide by 3, we get x equals 5/3. And this would also happen twice because it's the factor twice. All right. Oh, I lied. We are doing an x to the 5th here. Forgot about this one. Okay, well, I can factor out an x. And then what's left is x to the 4th minus 14x squared plus 45. And then I think this is factorable. Let's check it out. 45 would have factors of 1 and 45, and 5 and 9, and then 3. I forgot about 3 and 15. Okay, do any of these multiply to positive 45 but add to negative 14? And that would be negative 5 and negative 9. So it would be x squared minus 5 and x squared minus 9. And it's x squared because, you know, we have to get x to the 4th. Okay, so x squared minus 5 is not factorable, but x squared minus 9 is. We just looked at this one. This would be x plus 3, x minus 3. So now we're going to set each of these equal to 0. All right, x equals 0, done. Plus 5 on both sides, we get x squared equals 5. Square root, we did this one earlier, we get x equals square root of 5, or x equals negative square root of 5. Here we're going to subtract 3, and we get x equals negative 3, and add 3, we get x equals 3. So those are our 5 answers. We cross the graph 5 different times. All right, so that's the first page. We're all done with that. Looks beautiful. Let's run over to the second page. Should go a little quicker. So this is 5 problems on the second page. Let's start with the first one. So it says, find the zeros by factoring and then sketch a graph by plotting the zeros, kind of like what we did on the first one. All right, let's factor this guy. I'm going to start by factoring by grouping. I'm going to group the first 2 terms and last 2 terms together and separate those by a plus sign. So we can take an x squared out of here. We get x minus 4. And then I can take a negative 9 out, and we get x minus 4. That's good. That's what we're looking for. And then we can pull out that x minus 4. And we're left with x squared minus 9. And then x squared minus 9, we just did this like 2 times on the other page. This factors into x plus 3, x minus 3. So, in order to not get on the graph, let's set each of these equal to 0 over here. So we have x minus 4 equals 0, x plus 3 equals 0, and x minus 3 equals 0. If we solve this first one, we get x equals 4. Ugh, ugly 4. There we go. Subtract 3, we get x equals negative 3. And add 3, we get x equals positive 3. Okay, so what we're going to do is we're going to just mark negative 3, positive 3, and positive 4. And we're going to draw a graph that goes through each of those like that. That's all you got to do. You start from the bottom left, you work your way up on an x to the 3rd. All right. This one, I can pull out a negative x out of each term. And we're left with 2x squared plus 3x minus 20. And then let's see, factors of 20 are 1 and 20, 2 and 10, 4 and 5. So if we factor this thing, we've got 2x and x to get us 2x squared. And then for negative 20, I know I'm going to have one positive and one negative. I'm going to work with 4 and 5. I think that's it, because I noticed that I need to get plus 3x in the middle, and chances are you want something that's fairly close together. So let's try this. Let's try 4 and 5. That's going to be 10x and 4x. No, if I subtract those, I get negative 6. So that didn't work. Let's try switching those around. Hopefully that works. 5 here and 4 here. This would be 8x and 5x. And that would work if we have negative 8 and positive 5. So to get negative 8, it would be x minus 4. And to get positive 5x, we'd do plus 5 there. All right, so what we need to do is set each of these equal to 0. 2x plus 5 equals 0. And x minus 4 equals 0. All right, here we divide by negative 1. 0 divided by negative 1 is still 0. The next one I'm going to subtract 5. We get 2x equals negative 5. Divide by 2. We get x equals negative 5 over 2, which is x equals negative 2.5. And then the last one, we add 4, we get x equals 4. Okay, so let's find these on the graph. We've got 0, 4, and negative 2.5. 0, 4, negative 2.5. Now this is something we haven't really talked about much, but if it's negative, instead of starting down in the lower left and going like this, you flip it upside down. So you'd actually start in the upper left and go like that. Mostly what we'd be looking for is, do you know that it crosses the x-axis in those spots? My graph, if you graph it on Desmos, it's not stretched out enough, so we're just looking for those x-intercepts. Okay, this one's factorable, I hope. It'll be x squared and x squared. And then we're looking at factors of 72. So 1 and 72, 2 and 36, 3 and something. Let's see, 24, 4 and 18. 72's got a bunch. 5, no. 6, I think so. Yeah, 6 and 12. 7, no. 8 and 9. And that would be it. All right. So which of these factors will multiply to positive 72 but add to negative 17? And that would be negative 8, negative 9. All right, so we factored it. We could factor the last part one more time. X squared minus 9. Once again, we've seen this about 4 times now. Those would be our factors, but then we set each of those equal to 0. So we'll do this one at a time here. We get x squared equals 8, square root both sides, and we get x equals the square root of 8, or x equals negative square root of 8. And if I punch this into my calculator, it should be like 2.8 or something like that, because I know the square root of 9 is 3. So it's about plus or minus 2.8. Let me plug it in my calculator now and check. Yeah, it's like 2.83. So, and then our other factors are going to be x plus 3 equals 0, so that would be x equals negative 3. And x minus 3 equals 0, so that would be x equals 3. All right, so negative 3, 3, negative 2.8, and 2.8. All right, so this is going to look something like this. It's going to go through those two, come up, come down, and then go through those two. It's hard to see, but they go through 4 different spots on the x-axis. All right, 16, our last graphing one. This one I can pull out a negative x squared. And when I do that, I get x squared minus 25. And then I can factor that. I get x plus 5, x minus 5. So then I set each of these equal to 0. Negative x squared equals 0. Divide by negative 1 first. We get x squared equals negative, or excuse me, not negative 1, equals 0. Then I square root, and I get x equals 0 twice. Because it's x squared, you have to have 2 answers, and the square root of 0 is just 0. There's no plus or minus 0. And then we have x plus 5 equals 0, x minus 5 equals 0. So here we get x equals negative 5. And over here we get x equals 5. Okay, so it crosses at 0, at 5, and at negative 5. So it's a negative x to the 4th. It's going to start down here. It's going to come up. It's going to touch 0 and bounce off. And then it's going to go through 5. I know it bounces off because x happens twice as an answer. Okay, last one, number 17. This has gone on long enough. Let's finish it up. It says if a graph of a 4th degree polynomial crosses the x-axis at negative 1, 0, 4, and 8, what is an equation for the graph in factored form? Not standard form, but factored form. Well, we're basically going the other way. So it tells us that it crosses at those 4 points. So then what are the factors going to be? It's going to be x plus 1, x plus 0, so x minus 4, and x minus 8. That's it. It's in factored form. You don't have to expand it out. If it said write it in standard form, then you'd have to expand it out, which is kind of a mess, but it's very doable. All right, so that's it for the answer key for day 13.